Hello everybody. In this video I'm going to teach you guys how to make the Gran plot out of the data you obtained in your acid-base titration of KHP. So in this Excel spreadsheet I've already input the volume and pH, so these two right here. I've also indicated where I've seen my color change, so when it turns to faint pink at 3.30. Of course, this is just the perceived color change, so any calculations after this and using the Gran plot will actually determine the true endpoint. So in this graph over here, it's just a titration curve that I've already graphed out, and you can see that the endpoint is around the range of 13.26 to 13.43. So just anywhere in this linear area. Now what the Gran plot does is that it takes just this information in the linear area, so this portion right here, and it graphs that out. So you don't need to use any information here or any information here. You just need this part where it starts to inflect. And basically you just want to use the last 10 to 20% of the volume prior to the equivalence point. So what that means is that you're going to use 80 to 90% volume of the equivalence point. So to find the last 10 to 20%, in this case I'm going to use 10%. I'm going to multiply the equivalence point, 13.30, by 90%, 0.9. And that's 11.97. So in this table over here, I don't have 11.97, but I have 11.80, so I'm going to use this. So 0.9 of the equivalence point. And now that's just basically this area right here. So I'm going to take this data, copy and paste it into a separate column which I've already labeled. Now using these values here, I'm going to calculate the volume of the base that was delivered, or the volume of the titrant that was delivered, times 10 to the negative pH. So to start a formula, you just press equals, and then the volume, so VB, times 10 to parentheses negative pH. And because you can just drag this box down, it'll calculate these values relative to the box. So it's basically these values here. Now all you have to do is graph this now, volume versus VB times 10 to the negative pH. So you can't just select all these values and click graph, or else it'll look like a mess. So instead what you're going to do is hold control, select volume, or just select volume first, and then hold control while selecting these values here. So you can totally skip this area. And then I'm going to click insert, and instead of plotting it with smooth lines, you don't really want a continuous graph. You want independent values, because these connected dots isn't useful information. You just want the points being plotted. Alright, so here's my Gran plot, and you can see that it's pretty linear. This point over here is the 11.80 volume, and I'm going to treat it as an outlier because it's so far off from this linear curve. So I'm just going to delete it. Alright, so here's our Gran plot. And what I'm going to do now is find the slope. So I just have to select the points, right click on the points, and select add trend line. And this window will pop up called format trend line. If it doesn't pop up, then all you have to do is select the trend line, right click on it, and select format trend line. And then what you want to do next is to display the equation on the chart. And then a linear equation will pop up randomly around the graph. So you just want to move it, and move it somewhere you can see it. So you're going to have to select this equation and right click, and select Format Trendline Label. If you notice this equation right now, you can see that it's not very useful because there's not enough significant figures. And if you just use this now, you'll get an inaccurate equivalence point. So what I'm going to do is go to Format Trendline Label by right-clicking and selecting this option. Go to Number, select Scientific because I want it in scientific notation, and add as many digits as many decimal places as I want. In this case, I just want 5. And this gives you a really nice usable linear equation. So basically, to find the equivalence point, that's where y is equal to 0. And you just solve for x. So you can just use algebra to solve for it, or what I like to do is I like to put it in an online calculator. So I'm going to copy this equation and go to this website called Wolfram Alpha. And instead of leaving it x and y, I'm going to replace y with 0. So now it states that my calculated x value, or VE, is equal to 13.2939. And that's what I will use as my equivalence point. Alright, so from this information we found the equivalence point, but then depending on how good your titration was, you can also calculate the dissociation constant of your acid, Ka, by calculating out these activity coefficients. So once you find the activity coefficients, you can find Ka, and your job in this lab is to determine the value of Ka from your experiment and compare it to the actual reported value of Ka of Khp. So you can actually get very, very close. So hopefully this video helps. Let me know if you have any questions. I'll be happy to